Hello, everybody. I'm going to be walking you guys through how to use Spot to work on tone markings. We have functionality for Tokyo Japanese and Connemara Irish so far. Let me share my screen here so you can follow along. Are you guys on Spot right now so you can follow along? Cool. All right. So Spot, if we were going to be looking at accenting, or I should begin with this. So Japanese has accented and unaccented words. I'm sure you guys already know this, but when you phrase them together, the rise and fall of the tone will manifest differently. So if you have two unaccented words, there'll be a rise at the beginning of the first word and a remaining high tone for the rest of the two words. If you have an unaccented word followed by an accented word, there'll be a rise, and then the rise won't fall again until the accent on the accent, or the downfall on the accented word. If there's an accented word followed by an unaccented word, there'll be a rise and then a fall, and then another rise at the unaccented word. And then finally, if there are two accented words, there'll be a rise and a fall, and then a rise and a fall. That's depicted here with the low high and the high low. And then a low high with an exclamation point in the middle is a less intense rise. So we're going to be looking at, or we won't be looking at the data, but we collected this information from Ito and Mester 2017 and 2020. And so let's get started here. So we're going to be looking at groupings of 2, 3, and 4 words. So for Gen, we want uniformly left branching trees to mirror Japanese syntax. We want the S tree to be rooted in XP. We want non-root, non-terminals are also XPs. There are 2 to 4 terminals. We'll be using the automatic tab so that we can have 2, 3, and 4 terminal cases. The terminals will either be A for accented or U for unaccented. And the sister of an XP is always going to be a terminal. So to implement this in Spot, we have to look at these parameters here. So we are already rooted in the XP. The intermediate nodes are also already XPs, and the terminals are X0s. We're going to take off a junction so that we don't have cases. There aren't a lot of junction cases when there are only 4 terminals. There's only one case where that happens, but we're going to take it out anyway. And then we're going to go into our phonology here. Let's see.
We also do you want us to type in like in our own individual screens?
Oh, if only
just listen.
Only if you guys want to, just so that you can get a sense of how it works. If you guys are interested in using it, but
and you can ask questions as we're going along. We can answer.
Feel free. So we're gonna define our terminals.
Don't forget the head requirements.
That's right. We want all heads to be at the right edge, correct?
On the left, I think.
All right. Well, let's do that. All right, so our terminals are going to be.
Sorry, Ed.
Mhm.
Do we need to specify the built-in systems at the very top, or can
The
we just
built-in
leave it?
systems? Oh no, we don't need to specify that. This holds like a bunch of analyses that people have already done. And so if you wanted to look at ETOMester 2017-2020, it's in here, but this will already go through everything in the interface and fill it out for you. But I'm just going to do a manual version so you guys can see how to put it together.
Okay, thank you.
So next, I realize we don't want to put the terminals in here because we're going to be using accented and unaccented words. Yes.
Sorry, what should we do with Clitic and visibility to phonology? I accidentally opened it.
Oh, it's okay.
It's okay.
It shouldn't be a problem. We don't need any Clitics here. Is there a Clitics exercise, Jenny?
Yeah, Richard Bibbs is leading an exercise that uses the Clitics.
Mm-hmm.
So that'll be recorded too if you want to try that. But if having it open doesn't change anything, if you can it doesn't matter. As long as you don't check the boxes, it won't change anything.
Yeah, and we don't need to use visibility to phonology either. But we're going to go here to generate combinations and permutations. We're going to put in the kinds of terminals we want. So that's going to be accented and unaccented. And then the minimum number of terminals is going to be 2, and the maximum is going to be 4. And so we don't need to add that, but generate terminal strings. So here you can see we have all the permutations for 2 terminals, 3 terminals, and 4 terminals. So that's going to be AAAU, UA, UU, all the possible permutations. And then we're going to generate the trees. And here it's going to put all of these permutations into individual syntactic trees.
Sorry, Ed, I should have, the heads should be on the right, actually. That's
Let's redo that then. Yeah, the heads are going to be at the right edge. Perfect. There we go. Yeah, so this is what we want here. Then we're going to take a look at the...
Is that going okay so far? Any questions?
Oh, yeah. All right, sounds good. So then, let's see, we have our trees here. And you can see we have all these trees created. And so then now we're going to look at the output parameters. We want linear order for the terminals so that nothing gets moved around. We do have, for Clitics, we do have the ability to rearrange the terminal orders. Jenny, can we also rearrange terminal orders without Clitics?
Yes, but it hasn't been tested a lot. So yeah, if you want to look at the reordering that's demonstrated in the other exercise that Richard Bibbs is leading.
Yeah,
that's under this allow movement box. That's where you can allow the reordering, but we're not doing that for this one.
Yeah, and notably, if you do allow movement for every terminal, that's going to create a lot of trees, and yeah, exponential increase. So we want linear order to be preserved. That's default in Spot. We want every node of category K to have a child of category K-1. So that's going to be like a phi must have at least 1 word, or an intonational phrase must have at least 1 phi. That's also default with this enforced headedness constraint here. We want the root category to be a phonological phrase. So we're going to open up prosodic categories here and change root prosodic tree in phi. We want the terminal categories to be X0s. or sorry, the X0s are mapped to prosodic words. So the terminals here are words, and the recursive category we want to be phis, and that's already set as well. Perfect. And so that we can see what the accent is in any given word, we're going to click the annotated with tones button, and we're going to keep it in Japanese. For our constraints, we're going to include match Syntax-Prosody. And it's going to be automatically matching XPs to phis. So that's not, we don't need to change anything in here. We want to do the reverse, match prosody to syntax. Also, it wasn't mentioned, but for each one of these constraints, there's an info button here. And if you click it, it will tell you like exactly the definition of the constraint. So this one is assign one violation for every node of category K in the syntactic tree such that there is no node of the corresponding prosodic category in the prosodic tree that dominates the same set of terminals. Then we are also going to include binarity in the markedness constraints category. We're going to use bin-min branches, which makes it so that it assigns a violation for nodes without 2 children. If they have 1 or, well, I guess technically 0 or, yeah, if they have less than 2, then they will be assigned a violation. We're going to include bin max branches and bin max leaves. This one here is a little weird. It looks at nodes and checks to see if how many descendant terminals they have. So a node at the very top will have all four terminals, and so it will get a violation. But since every one of them gets a violation, that's not a problem for optimality theory. Then we're going to go into sisterhood. We want equal sisters adjacent. This looks at different nodes and checks to see if its sister is of a higher category or a lower category. If they're equal, then there's not going to be a violation.
So yeah, if I could jump in for a second, Ed, you can see there's a few different implementations of equal sisters on the spot interface. And to get this particular one, the equal sisters adjacent, you have to click on the show more, and then it will expand out the options and show you these other variations. And we put this one in because it's the version that was implemented in the analysis we're modeling this off of, but the other ones are there also if you want to experiment.
We're also going to include equal sisters 2, and to look at the actual accent issue here, we're going to include accent as head and no lapse left. And then everything here is, all the constraints have been input, the output has been defined, and the input has been defined. So let's see what we get. I'm going to save that. So here, now we have all of our Tableau. And since we clicked the, let's see, where was it? Since we clicked the annotated with tones button, we can also see in the Tableau the rises and falls of each of these prosodic trees. And then if we wanted to look at a typology, then we would take the file that we saved and put it into OTWorkplace. Are there any questions? Yeah.
Sorry, I should have asked this like a long time ago, but
of course.
What are those ones and twos at the end of the structures?
The ones and twos of the trees?
In the, yeah, or actually we had them in the square bracketed trees as well.
Let's see.
On the A's and the U's, right?
No, ones and twos, like
yeah. So
Here?
yeah, so like there's a one, yeah.
Okay.
Do you want to answer that then?
Yeah, of course. So like, let's see, let me find one with a 2 as well. Notice there's a lot of trees that Spot generated. Here.
In the input section.
Well, there are threes as well.
Yeah. So that's to distinguish, since we're only using A's and U's, we want to be able to distinguish them. So this first one is just A, this second one is A1, this third one is A2, and this one is A3.
So the way the match constraints evaluate the terminal, evaluate matching, it is checking that the terminal string it's checking. It requires that each terminal node has a unique identifier, and so if you have a repeated ID, like you put in a couple of, in this case, it's 4 different A's as the terminal ID identifiers, then non-initial ones get the index added to them.
Okay.
So that's why the first one doesn't get marked, and then the subsequent ones get a number added to, just so that each one is unique, and then it will be able to, Spot will be able to correctly evaluate the correspondence relations. Like the correspondence is established based on the unique strings of terminals that are contained.
Okay, I see. So in the actual sort of structure, we can get rid of those ones and twos.
Yeah, definitely.
Okay. Yeah.
Yeah, so those get added automatically if you put if you have a redundant, if you have a repeated ID, then Spot will just add that to make sure the match constraints can work correctly.
Okay, thank you.
Yes, and we can see we also have all these constraints have been added. So, for example, accent as head, we'll check whether or not each accented terminal is the head of its own phrase. There's only going to be one head in this phonological phrase. And so 3 of them, A1, A2, and A3, are going to get a violation. Whereas here, this A3 is the head of its own phonological phrase, and A here is the head of this phonological phrase. And so we will get 2 violations for these 2 here. And that's gonna change for each one. And then we also have no lapse, which makes sure that a low tone doesn't remain for an extended period of time. Correct me if I'm wrong, Jenny. It's across phonological boundaries.
For every fully low toned word. So you need an accented word followed by an unaccented word to see a violation of that. So I think maybe it bears emphasizing that the Spot will recognize, if the ID starts with A, Spot will recognize that word as being like lexically accented, or if it starts with U, then it recognizes it as lexically unaccented. But if you put in, if you wanted to spell out the full word, then you would have to mark the accent and accentedness separately if you didn't want to use this A notation. But if you use the A and U notation, then it can extrapolate from those IDs.
Also, the Ito and Mester analysis assumes that the left edge of a phi is where a rise will happen. And so after the fall of this accented word, there's no left edge of a phi here. And so the unaccented word is going to remain low. And that's where you're going to get this violation to no lapse.
Was everybody able to get these violation tableau? You can also do this without doing the, you can also do it with, without generating all of the strings. You can just put them in manually and just have a couple of strings if you want.
You mean in the manual tab here?
I mean, in the, if you go down a little bit, Ed, in the, where it says strings of terminals, instead of generate combinations and permutations.
Yes, true. So for example, let's see, A, U, A, or maybe A, U. And we can try this out.
Oh, you have to just go to the generate trees.
Ah, here, yeah. So then you'll only get the trees that you defined here if you use specify terminals. That's only going to give you 3 tableau, which is a lot more manageable if you're looking at a specific kind of syntactic structure. Jenny, do you want to show like maybe importing into OTWorkplace?
Yeah, if there's no questions, I can demonstrate that. Does anybody have any questions about how to get to this point, or like other features that are related to this, or just any general spot questions? It could be related to the exercise or to the lecture, either way.
I don't seem to be able to get the results, but I'm not sure if that's because I didn't check necessary boxes or what.
What's happening when you click on the get results button?
Oh, okay. Oh, I guess it just took time.
Oh.
All right.
Sometimes if there's a lot of inputs, it can be kind of slow.
Yeah, first I think the page froze, and yeah. I did it again, like the selection. So I thought maybe I made mistakes, but somehow it gave me the results. So maybe it's not the same as Ed did, but I got something.
I mean, the goal is just to show how you can get some of these annotations. So, yeah.
And if you want to take the easy route, of course, you can just click the Japanese Ito and Mester analysis here.
Then you can see what settings that one brings up. That also works. That one has a few more constraints, I think. I left out some of them just to cut things down a little bit.
I see. This one also checks no level skipping.
Yeah, because it doesn't. The trees are rooted in the intonational phrase there. I think it has match. It has match max. Oh, I think you want the manual tab if you wanted to get the. Anyway. Yeah, if there's no questions, I can demonstrate how to load this into OTWorkplace. Yeah. Okay. Let me pull it up. Okay. Ed, do you want to stop your screen share and I can demonstrate the OTWorkplace? Yeah. Okay, so this will be demonstrated more tomorrow, but I'll just show it quickly now too. So if you get the, suppose you've downloaded the CSV file and you have something like this, it should be a, oh, sorry. You should have yeah, it should be something with the CSV file extension. You can copy it over to the remote desktop or transfer it with Google Drive or something. And if you double click on it, then it should open with Excel and you would get something like this, except it didn't show this doesn't have the tone markings. That's irritating. Oh no, there they are. So it's a little bit unpredictable whether it's going to show the second line in Excel properly, but they're with the lows and highs. But it's there. So when you can open the CSV file in Excel, and then to do the OTWorkplace part, in this top ribbon, there's this add-ins bit. So if you click on that, then OTWorkplace should come up. And we can start a project. So this is where you can put in a name. And well, so it asks you if you want to start it in a new sheet or whatever, and you can pick the first one and say you want a new name. And I'm going to say, I'm just going to call it accent and say, okay. And then it will do a little bit of formatting like this. Is everybody, I don't know if everybody is able to follow along. If I'm going too fast, please let me know. It's good. Okay. So then this is now OTWorkplace will recognize this as a violation tableau. And I can go in the OTWorkplace menu again and pick the factorial typology and pick fact type calculate. That's the first option there. And then it will calculate the factorial typology. So this sometimes takes a while because it's crunching a lot of numbers and tells you, okay, there were 2,730 harmonically bounded candidates, so the ones that can never win under any ranking. Some of them have identical violation profiles. It doesn't, I'm fine with that. And then you can just click okay, okay, and then it will eventually show you the typology. Sometimes Excel will get a little frozen during that process. Like right now, it's telling me that Excel is not responding, but typically after a couple minutes, it figures it out. There we go. So in this case, it turns out this system gives us 141 languages because it was pretty complicated. And OTWorkplace will give you some information about how many combinations of optima there were and how many feasible combinations of optima. You can see these are gigantic numbers.
That would be including all the candidates, right? Including the harmonically bounded ones?
No, so this is just the possible combinations of optima, but like most of them don't show up as possible combinations under the same ranking. So I'm going to say okay, and then since there's a lot of languages, I don't want to get the ranking information for all of them. I'm going to say no here. Okay, and so now that's ta-da, you can have a typology of all the languages that the system generates. Okay, I'm sorry, it looks like I generated this one with the heads on the left instead of on the right. So this is a mirror of the one that we were trying to do. Sorry about that. But you kind of get the picture. And then at this point, we probably want to, there's too many languages to really easily see what's going on. So I would use the filtering function to just show the languages that have like the shapes, the outputs that I'm expecting. So if I click on the little triangle up at the top, then I can unselect them and say, okay, let's see, maybe I only want to see the languages where each accented word phrases separately for this input, and I could pick this one. And then that brings us down to just only 4 languages, actually. That cut things down a lot. And then I could filter further and say, oh, well, let's see, maybe I only, well, actually, it turns out once we filter it to only the languages where each accented word gets a separate phi here, then there's not so many options left for some of these other ones, but you could filter them further if you wanted. I don't know if most of these actually are cut down. So that's kind of the gist. I don't want to get into too many details with the OT workplace right now, since we'll talk about that more tomorrow, but that's the kind of the basic beginning of using this. Yeah, any questions or things, something I can re-demonstrate something if I went too fast. Were you able to do a typology? No, okay.
It's just my Excel got unresponsive and
oh, no.
crashed. So yeah, I'm doing it again.
Okay.
But yeah, I got an idea, I think. Thanks.
Yeah, you can do it with a smaller, smaller typology. So the exercises for tomorrow we set up to be like a smaller typologies that shouldn't crash your Excel, I hope. But so this is kind of a demonstration of how usually a lot of the papers that are out there, people end up proposing, you end up proposing like many constraints, and then that gives you potentially a lot of languages, which could also be really interesting to look at.
Mm-hmm.
Yeah. Okay, I'm gonna, unless anyone has a typology, OT workplace question, I'm gonna stop my screen share.